All right. Welcome everyone to the third series in the course Introduction to Java and Object-Oriented Programming. My name is Pratik and I'm a software engineer. And today we will be talking about conditions and loops in Java. So till yesterday, we looked at how we can declare variables, how we can use data types, and how we can use various operators. Today, we'll be taking a further step towards coding in Java, and we'll be looking into two main fundamental operations that you have in Java. First one will be the conditions, that is, if you have to evaluate any conditions, and second is loop, when you need to repeat a piece of code. So before we get started, a quick reminder about Newton School. So this course is being done in association with newtonschool.co. So if you're interested in getting a certificate for this course, also look into the assignments that are being offered as part of the course. Please go to newtonschool.co. The link to Newton School will be given in the description for this video, so do check it out. Log in, sign up here, register as a user. And then once you've registered, when you are there, you will be redirected to your dashboard. In the dashboard, under more tracks, look for the course Introduction to Java and OOPS by Pratik Bhattacharya. And this code, and in case you're not able to find it under more tracks, just click on Load More. You can click on the Apply button here to apply for the course. All right. Let us get started with the actual content of the course. So the first thing that we'll be looking today are called conditions. So conditions are used in any programming language for basically evaluating a given condition. And if that given condition is true, then do some processing based on that result. So in multiple scenarios, whenever you're writing programs, you will always need to make a choice that based on the user input or based on some conditions or based on some scenarios in your application, you might have to execute either a piece of code, or if that condition is not matching, if some other condition has happened, then you might need to execute some other piece of code. So this kind of situation is going to happen multiple times in multiple types of programs that you're going to be writing. So in Java, basically, there are two major ways of how you can evaluate conditions or how you can represent conditions. The first one is known as the if-else condition, and the other is known as the switch case. We'll take an example and we'll take a practical look into both of them. Just to give you some theoretical perspective of what exactly is meant by the if-else condition or by the switch case condition. So if-else condition means you write something called if, and then you write a condition here. Now, when I say the term condition, you need to realize this has to be a relational operator or a logical operation needs to happen here. So in yesterday's video, we did take a look into operators, and we talked about relational operators and logical operators. The output of both this relational operation and logical operation is a Boolean. So this statement, whatever you're writing inside a if, this needs to be a Boolean expression. That is, whatever expression you're writing, the result must be evaluated to a Boolean value. That means either it should be true or it should be false. Now, if the condition that you're writing here, if that is true, then whatever piece of code you're writing within this block, and by block I mean so in Java, anything which is written between two curly braces, any code that is written between the starting curly brace and the end curly brace is considered to be a block of code. So if this condition is true, that is whatever condition you're writing here, if that evaluates into true, then this block of code will be executed. Now, if this condition is false, this is where the next part becomes actually optional in nature. So now there are three things that you can do. First thing is that if this condition is true, you execute this code. If this condition is not true, you don't execute this code, and that's it. You finish the condition. That is, you don't need to do anything else. However, in some complicated scenarios, you may face a situation where you have to evaluate multiple types of condition, and based on which condition is true, you might have to execute that block of code. So for that, we have an option called else if. So if this condition is not true, then what your Java compiler will do is it will look if there is an else if statement. And if there is an else if statement, it checks what condition is written on the else if statement and tries to evaluate if this condition is true or not. If this condition is true, that is, if this condition for this particular else if is true, then this block of code will be executed. And you can have multiple else ifs following a if. So if you have to evaluate, let's say, like 10 different conditions, then you can actually have one if followed by 9 else ifs. There is no restriction in Java as to how many else if can follow after a particular if. But just you need to remember one thing: as soon as the first condition in if and all the else if that follows, as soon as the first condition in any of them becomes true, is evaluated to true, and that block of code is executed, none of the other else ifs are even checked. Java compiler is going to automatically take you out of that particular condition block. So what I mean by that is, so if you have got if and else if, and if the condition in this if is true, then this block of code will be executed, and this else if will not even be evaluated. Java is not going to look into this else if. It is simply going to execute this particular piece of code in the if and then come out of the loop. And if the condition is false, if the first condition was not true, then it will take a look into the next else if which is possible, evaluate its condition. If that condition is true, execute that block. If that condition is false, then it is going to see if there are any other else ifs which are followed. Now, this might happen that you have, let's say, 10 conditions and none of the conditions are true. And you are in a situation where if none of the conditions are true, you need to execute this piece of code, another block of code. So that is where the else statements comes into the picture. So if all the conditions which are written in the if statement or in the else if statements, if none of the conditions are true, if all the conditions are false, then whatever code is written inside the else block, that gets executed. So this is known as the if else if kind of a loop. And now next we'll be looking into the switch case loop. So in switch case, what happens is here you can give some value or some variable actually to the switch statement. And then you write multiple cases based on what could be the value of this particular variable. So here what it means is, when you are writing a test variable here, you are switching for a particular test variable. You are seeing whether the value of this variable is value 1. If it is value 1, then this piece of code will be executed. If the value of this test variable is value 2, then this piece of code will be executed. Like that, you can have multiple cases. And similarly, like if else if, in Java, you do not have any restrictions as to how many cases can follow a particular switch statement. So, and in case none of these cases, like all the cases that we have looked at, in case none of these cases matches the value of the given test variable, then whatever is written in default, that will be executed. Now, one thing to keep in mind is about the break statement. Now, this is very important. What the break statement does is, it actually breaks you from that particular condition block. So let's say your test variable value was indeed value 1, then what will happen is this case will be executed. And after that, the way switch cases works is that all the pending cases will still be executed, even if one of the cases was evaluated to be true. So since you don't want to do that, or in a situation where you don't want to do that, you can actually write the break statement. So what the break statement is going to do is that instead of evaluating any other following cases, it is simply going to break out of this switch block. So this actually saves a lot of processing, and it is also a good practice to have that break statement after every case that you are writing. Right? Now let us go and take a look into a very simple demo. Now, before we go into the demo, till yesterday and day before, all the programs that we were doing it in Visual Studio Code. VS Code is a pretty good IDE for coding Java and other programming languages. So today we will be introducing you to another kind of IDE, and that is this is an online IDE which is available in Newton School. So if you are registered in Newton School site also provides you with an integrated development environment where you can not only practice Java programs, but you can also practice programming in other languages like C, Python, JavaScript. So let's go and let me just show you how you can use that editor. So once you have registered and you have signed into the Newton School website, when you will be taken to the dashboard, you can go into this playground link. And playground link is where you can actually create, practice code, and then you can execute that code, see the result. You can add multiple inputs and see how the output behaves. You can get errors and stuff like that. So what you need to do is, so there are two places. One is a markup playground and is the algorithm playground. You don't need to go to the markup playground for this particular course, or if you are trying to practice only program DS Algo or any other programming language, you can go into algorithm playground. Out here, create a playground. And for here, probably I'll just going to be naming it as module 3. The title, you can give whatever title and description that suits your need. Create the playground, and that's it. This is going to be created here. So here you can see that there are three specific, let me increase my volume, text size a bit. So there are three basic windows that you can see in this screen. On the left hand side, you have got the code screen. So this is where you will actually be writing your code. And then on the right hand side, there are going to be two windows. First is where you're going to be giving your inputs, and on the bottom window, bottom right window, you will be seeing the output. So here also we have got 4 different tabs in the output. The standard output, so whatever you're printing, so if you do something like system.out.println, that is something which is printing into the console, that will come up in the standard output. And then you have got the compile output. So compile output is in case you have made any mistake in the program. That is, let's say you have forgotten to give a proper semicolon, or you made a case sensitive error or something like that. When you're compiling your program, then the error is going to come here in the compile output. Standard error is in case when you are executing the code, if in runtime, if it finds some sort of an error, that is, it did not find that error in the compile time, but rather when the program was running, it found there was an issue there, it can put in the standard error. So these are the 3 main tabs that you need to use. So, and in the code tab, you can see that you have got a drop down here. And if you click on the drop down, you get to choose which language you want to do the code in. For example, if you want to do code in BASIC or C or C Sharp or C++ assembly, there are a lot of support. There's a support for a huge number of programming languages like Scala, SQL. You can also do SQL coding here, Kotlin, TypeScript. So for our situation, for our scenario, we'll simply choose Java, and here OpenJDK 13.0.1 is being used. So it doesn't really matter which JDK version is being used for you people, because for this course, we will not really be looking into very specific features of JDKs. We will be doing basic Java programming only. Okay, now for starting the code, if you remember what we did yesterday and day before yesterday's classes. So you first need to have a class, and let's say I'm going to be calling it as a main class. And then I'm going to be creating the starting point, and starting point of every Java program, I'm repeating once again, is the main method of the class. So if I do something like that, public static void main string arguments, and I pass something here. So whatever code I write inside the main method, this is the starting point of execution for your program. So here, the first program that we will be doing today is a program where we're going to be checking whether a user is eligible for voting. So what I mean exactly by that is, so if you're familiar with the laws that you have in India, that only when a person is becomes of age, that is when the person is 18 years or older, only they can vote. If your age is lesser than 8 years, you are considered a minor and you do not have voting rights. So we are going to be building a similar kind of a program where we will be asking the user, please enter what is your age, and based on the age of the user, we will be deciding whether that user is eligible to vote or whether that user is not eligible to vote. Okay, it's going to be a simple program, but one thing that should strike out immediately when I was talking about the problem statement was that I'm talking about some sort of a condition here. That is, I'm asking you to build a program where we're going to be checking whether the user is of age or not. And whenever you're seeing, you encounter statements like if the user is doing this, whether this has happened or not, in such situations, you need to evaluate some conditions. So here, what is the condition that I'm evaluating? The condition that I'm evaluating is whether or not the age of the user is greater than equal to 18 or not. That is the condition that I need to evaluate here. So let's get started with the normal program. So again, if you remember yesterday's classes, the first thing that you need to do when you're taking input is you need to have the scanner class. And for the scanner class, we need the util package in Java. So import java.util.scanner. So this is going to take the scanner class. So let me create an input first. I'm just creating a normal input, nothing else. And I like to close my input. So I'm just going to do input close. This will be the last line of the program. The next thing that you need to do is you need to take an input from the user. And when I'm going to be running the program, I'll actually show you what is the right way of means if you're coding in this NSID, what is the right way of taking inputs. So let's assume that the input that the user is going to give is the age. So something like this, age is equal to, and if you remember that age is obviously going to vary from something like 0 to, let's say maybe I don't know what is the age of the longest person in the world is, but probably we can assume it's going to be somewhere between 100 maximum. So when you have to deal with and you're dealing with an integer, a value whose maximum value can be, let's say, 100 and 150, you can safely consider that int is going to be a good data type for it. You can go back to yesterday's video lecture if you want to look into the maximum and the minimum sizes of some of the data types that we discussed. We have int, we have long, we have byte, short, and stuff like that. In this situation, since we're dealing with age of an user should be between 0 to 150, so int is a very safe bet. So this is how you take input. This is something which we had covered in yesterday's video as well. So you're taking the age of the user, and now the next thing that you need to do is you need to check whether the user's age is greater than equal to 18 or not, because that's how you decide, right, whether the user is eligible to vote or not. So the way we do that is, if you remember the syntax, you first write an if statement. Now here is where you need to evaluate your condition. That is, you need to write the condition, that what is the condition that I'm trying to check here. And what is the condition that I'm trying to check? I'm trying to check if the value that is there in this variable age, if that is greater than equal to 18 or not. So let's say it is greater than equal to 18. So this becomes a very simple way of doing it. If age is greater than equal to 18, this means that if the value which is there in this particular variable called age, if that value is greater than equal to 18 or not. And what happens if the value is greater than equal to 18? Then the user is eligible to vote. And how do I give an output to the user that yes, you are eligible to vote? I can simply do a system.out.println, which will print a message to the standard console. So I'll do that, system.out.println, and here I'm going to write you are eligible to vote. Yeah. Now let's try to run this program and see whether it does what it is supposed to do. Now, one thing to note here is, we'll be taking an input, and that input will be taking an input. That means we're expecting the user to give some information to us. So if you're using NSID, then the correct way of doing that is if you have to give some custom input to the program when it is running. In the custom input, in the custom input text box that you have here, you need to enter the value that needs to be inputted back to, that needs to be given to the program as an input. So let's say for first time I'm trying number 24. That means 24 will be given as an input to this program, and 24 will be going into this age variable. So now if you have to run, I will simply click on run. It is going to take some time to compile the program, and I think I made a mistake here. Unable to. Achha, sorry. Okay. I think this is a mistake. Let me go run again. Yeah, it is okay. So if you're coding in Newton School NSID, so your starting point should be the class main. That's the reason, and I made a case sensitive error actually. I called a main. The M was a small case. That's the reason why we face the error. This is a thing that we have in the NSID. So if you're coding in NSID, just remember that the starting class should be called capital M. So here it is. So we can see the program working. So 24 was given as an input, and it checked that 24 was greater than equal to 18. So it printed a line, you were eligible to vote. Now let us just do a little bit of thing here. And I'm saying if the age of a user is 6. Now what's going to happen? Let me run this. So run is over. But you see, nothing has been there in the standard output. So the user might be confused. It doesn't know what exactly has happened. That is, the program ran, but the program did not return any output. And why did that happen? Why didn't the program return any output? It's simple. Because we were just checking for one condition, that whether the age of the user was greater than equal to 18 or not. We were not checking, or we were not executing any piece of code when this condition was actually not true. And if you see here, when you have entered the age of the user as 6, it doesn't know that. This condition was false. 6 is obviously not greater than equal to 18. So this condition faltered. And it doesn't know what to do, because there is nothing else written after this. So this is where the else statement, which I was talking about, comes in handy. So now if I give a else statement and I print something like this, you are not eligible to vote. Sorry about my spellings and everything. You're not eligible to vote. Now what will happen is, if this condition is false, then the Java compiler will see that, okay, this condition is false, but there is an else statement. That means if this condition doesn't work out, then whatever piece of code or whatever block of code is there inside the else block, I can go ahead and execute that. And this is what is going to happen now. So if I give a custom input of 6 and now I try to run the program, you'll be given an answer, you are not eligible to vote. So this is a very simple program, but this kind of very simply it demonstrates the capabilities and how you can use the if-else statement that is present in Java. I'll be taking a moment to go back to the video to just check whether there are any questions in the live in the live chat. In case not, we can go ahead with the next demonstration that we have. All right, there are no questions. But I would like to encourage people who are watching the video and people who are on the live video, live chat, that if you have any questions, please do put it out in the live chat. In case you have any questions relating to the content of the class, or if you have any question related to the feedback, if we are going too fast, too slow, or if you're having any technical problems, I would encourage all of you to put that information back in the live chat or post it as a comment. Okay. All right, let us move on. So we have our very first simple program done. And just one small announcement: all these programs that we're seeing, these are available on GitHub as well. So GitHub is a simple repository where you can actually share code with other people. So all this code that we are doing in the live session is available on GitHub, and we will be giving you the link to that particular website where you can actually go and see this code later as well. All right. Okay, we will be moving out. Let's try to go and do the next program. So let me delete all this logic. So the next program that we will be doing we'll be involving switch case here, and we'll be seeing how we can use switch case to do our programming, to do a program. So the problem statement here is that you have to take a number from the user. Number should be between 1 to 7, and you need to print which day it is. So for example, if we do a day of the week, it is. So if we assume that a Sunday is the first day of the week, then if the user inputs 1, your output should be Sunday. If the user inputs 3, that is what is the third day of the week, then considering Sunday was the first day, Tuesday is going to be the third day of the week. And in case the user inputs an invalid thing, that is which is not falling in the range of 1 to 7, you should just print a message saying that's an invalid number. Okay, that's what the simple program is. And you can do this program using if-else logic that we just showed earlier, but here I'll be just demonstrating how you can use switch cases. So we will do the same program, but using switch case this time. So first thing is, again, we need to take an input. So the input will be, let's say, day will be input dot next int, and here also you need to use your judgment. So we are saying that the range in which the user is going to put their input is going to be between 1 and 7. So if you're using 1 and 7, then int is a very safe data type choice. Now if you go back to the switch statement, and if you remember the way we write it, so we do a switch and then we put a day. This is the test variable. So this is the variable which we are checking, that what is the value of this particular variable. And now we need to write cases, and for each case we need to execute a piece of code. So first case, let me write it as case 1. What does this mean? And let me write the whole thing, and then probably I'll explain. System.out.println, and we are assuming that the first day of the week is Sunday, so that's Sunday. Now a lot of people do also assume that Monday is the first day of the week. You can go ahead and do that as well. It is just a convention, and all these things will be given in the program. So whenever the question comes or whenever the program text comes, this will all be given, all this type of assumptions, that whether Sunday is the first day of the week or Monday is the first day of the week. So whatever you consider to be the first day of the week, you can change the program accordingly. So let's just try to understand what exactly happened in this pieces of line here. So I am looking into the value of day, and day is something which has been given as an input by the user. And in case the value of that is 1, then this is the line of code that is going to be executed. And what will be executed? You are simply going to print the text Sunday. Let's write the other cases. I've got case 2. Case 2 will be what? I'm just going to do some copy paste because I don't want to type a lot. Case 2 will be Monday. Case 2 means if the value of day is 2, then execute this line. So similar way, in similar fashion, there will be like 7 such cases. So I'm going to do some copy pasting here because I don't want to type a lot. There will be 3, 4, 5, 6, 7. All right. And I'm going to change the values. Tuesday, Wednesday, Thursday, Friday, and finally Saturday. Right, so we are done with all our cases. Input is closing. So let us try to run this. So I'll give a custom input first. I'm going to give an input of 1, let's say. So ideally the output should be Sunday. Let's see if that works. We'll run this. Here it is. It is Sunday, right? Let me give an input of 4 and let's see what happens. I think it should be Wednesday. If my maths is right, it is Wednesday. Yeah, so it's working fine. Now again, let us take a look into a negative scenario. Let me say something like it's a 9. Now there ideally should not give any result. If I give 9, what happens? Nothing happens. Now again, if we go back to the analogy of when we're doing if else, you see when you're giving an invalid input, your program is kind of doing nothing. So from an outside world, if a user is actually using your program, they might get a little confused with what happened. The user might have given an invalid input without knowing about it, right? So in case in such situations, it is your duty to go and tell the user back, okay, you have entered a wrong input, so it's an invalid data, so that's the reason why we cannot do any processing. So here what we can do here is when you're writing switch cases, you have got this term called default, which is actually used, which means that if none of these cases are true, if the compiler couldn't find any true case here, then whatever piece of code, block of code you write inside default, that is going to get executed. And here also we are going to be doing a simple print, let's say, and what we'll be printing here is invalid data. All right. Let's now run the same thing with the same input 9, and this time the output is invalid data. Exactly, that's how it is supposed to work, and that is how it is working. All right, I will again go back to the live chat to see whether there has been any questions posted there or not. If not, we will go into the other portions of the class. Okay, there's a question from Yash. Should I start my coding career with C? Well, Yash, see, there is nothing like that which programming language you choose. And in my first video that we had, I was actually explaining about that itself. That it is that your concepts has to remains the same in all the programming languages. C, C++, Java, they all differ in syntaxes, and obviously C is a little procedure-oriented programming and Java is object-oriented. That is one difference. But it doesn't really matter whether you're starting with C or you're starting with Java. In most of the institutions, yes, they prefer to start with C, but it is not a mandatory thing. You can start with Java. You can start your coding career with Java as well. There is, you won't be facing any issues there. In case you need to go back to C, like let's say you got placed in a company which is still using C or C++, the syntaxes will be a little different, but trust me, you will be able to pick up the language pretty fast. And I'm talking from experience about this, that picking up a programming language is not that tough, provided that you are pretty good in one of the programming languages and all the concepts are clear to you. Okay. All right. We will thank you for the question. We will move to the with a little difficult problem where we will be showcasing the use case of multiple if and else. So let us just take a look into the program first, and then probably we will problem statement, and then we'll start the coding. So this is kind of like a real life program. So assume that you are trying to build an automation system for school education, for an education system, where the teacher is going to enter the marks that has been obtained by a particular student. And then based on the average marks, you need to give a grade to the student, like grade A, grade B, grade C, and stuff like that. So for this particular problem, what we're saying is that take the marks obtained by a student in 4 different subjects, calculate the grade based on the average marks. So if the average is between 90 to 100, then grade A, 80 to 90 is B, 70 to 80 is C, 50 to 70 is D, and anything less than 50, we're considering the student has failed in the subject, in the examination. So it's again like it's not a very difficult program. It's a simple program, but this is going to be having multiple else and if else, because you see there are multiple conditions here. There is a base condition which says if the number is between 90 to 100, it is A. Else if the number is between 80 to 90, it is B. Else if it is 70 to 80, it is C. So since there are multiple conditions and you need to evaluate each of these conditions, a single if and a single else is not going to suffice. You will need to take help of else if here. Okay. Let us try to go ahead and try to code that. The coding shouldn't be that tough for this as well. So let us remove the portion. Okay, ID day. Okay, we'll be taking, so since we're dealing with subjects here, we'll just call it a sub 1. And I'll be taking 4 inputs, sub 1, sub 2, sub 3. Okay. Now one thing to just be careful or rather to note here is that when you're using the NSID, if you're inputting multiple things from in multiple lines, you need to give multiple data here in the custom input as well. And I'll show that in a moment. So I've taken the marks of 4 subjects. So if I need to calculate the average of 4 subjects, what is the first thing that I need to do? I need to calculate the total marks first. So total marks will be what will be the total? It's going to be simple summation. So sub 1 plus sub 2 plus sub 3 plus sub 4. That's the total marks. And the average will be what? Average will be, it's a double average is equal to total divided by 4. An interesting choice of data types here you can see. So our total has been kept as integer only because subject marks, we can assume that all the subject marks are out of 100. So the maximum number that a student can get is 400, like a summation of all the subjects. So 400, again, as I said, 400 is a pretty small number in the integer range, so you can use int there. Now, when you're doing the average, you are actually converting the data type. That is, you're not using integer anymore, you're using double. And why is the reason for that? It is because you're trying to divide. And if whatever the total is, if that is not a number which is perfectly divisible by 4, you're going to get points in it. You're going to get points in your answer, right? Like you're going to have decimal point in your answer. And that's the reason, since we might have decimal point in your answer, the next best data type that we have that we can use is either float or double. So you can use either float or double because here the data will be pretty small and you don't need so much of precision. But so you can use float here if you want to, but yeah, for this program, I'm just using double. So you can use float. If you're comfortable with float, you can go ahead and use that as well. Now let us go back and take a look into the conditions once more. So condition says if it is between 90 to 100, you're going to get A, 80 to 90, B. So let us try to code for these conditions. The first thing I'm going to be doing is I'm going to check if the average is greater than 90. I'll make it greater than equal to 90. If that is the case, what I'm going to be doing, I'm just going to be printing, hey, you have received grade A. Simple, because that's what is, if the number is, if it is greater than really 90. And now one thing we can do here is we can do a check that if it is between greater than 90 and lesser than 100, we can do that if we need to, but it is probably not needed here because there is no other top conditions. This is the topmost condition that we have. This is kind of the float condition. So if there was another condition which says if it is between 100 to 110, then the grade would have been something else. Yeah, then probably you should have used else, means if it is greater than 90 and it is greater than 100. But since there are no more conditions on top of it, this is kind of like the ceiling condition that you have there. That's the reason you don't really have to do it. Next is the else if statement. Now this is where it gets again interesting. So else if statements, next one says that the average needs to be lesser than 90 but greater than 80. So first do greater than 80. Now the condition is, so there are two conditions at play here, two relations at play here. The first relation is that the average is greater than or equal to 80, and the second relation is that the average should be lesser than 90. So if there are two relations, and if you remember things that we are discussing in the last video about logical operators, you can use logical operators to connect two different type of relational operators. So for here we'll be using the ampersand logical operators, which actually means and average is less than 90. If that is the case, then what is the grade? The grade will be grade B. Simple. Same we'll be using if the average is greater than or equal to 70, but it is greater than 80, then it is grade C. Okay, I will copy those. Okay, I made a mistake. It should be else if, by the way. It's not just else. Last else if it is greater than 50 to 70, that should be grade D. Now here, if I again go back to the conditions and just take a look into it, if you see the conditions after 50 to 70, it is kind of ending. There is only one more condition left. So till now we have been using else if, but for the last condition between 0 to 50, we don't really need to use else if anymore, because we know that if if none of these conditions are true, then it is obvious that the student has failed, that the marks of the student is lesser than 50. So you don't need to specifically again write another else if to check whether the average of the student is actually lesser than 50 or not. Since all these conditions have failed, you can automatically assume that actually the marks of the student is lesser than 50. So here, instead of writing another else if, I'll simply write an else, and in the else what I'm going to write that the student has failed. That's it, done. Let's see, let us try to, okay, I need to give the inputs first. So let us assume that there is a very good student who has received pretty high marks. So the average should be greater than 90 in this case with this kind of input. If we run this, hopefully this will work. Grade A, yeah, it is. Let us take an extreme case of probably where the student got pretty low marks, not a very good student. Should be failed. The student should have failed here. Student does fail. And Let's just take some random data and see what happens. 76, 95. I guess the student will get a B or C probably with this marks. Let's see. Yeah, it's a grade B. Okay, all right. So this is again a little complicated program using ifs, where we got to see use of multiple else ifs, and then inside the conditions we got to see how we can use logical operators to connect between two relational operators. I'll again take a quick peek at the questions if there are any. If there are no questions, we will get on with conditions. All right. Okay. I don't see any questions, so that's good. So I will move on with conditions. Sorry, loops next. Okay. Loops. All right. Let's just do a little bit of theory to understand what are loops and what are the kind of special loops that you have in Java, and then we can go ahead and do some programming around it. Okay, so loops, so conditions are used when you are faced with a scenario where you need to take two different or three different or multiple different choices based on the data that has been given. There are other scenarios that you might land up when you're doing some programming is when you might need to repeat the execution of a block multiple times. So you have a piece of code and you might need to execute it multiple times. Like let's say a very simple thing. I say you hey, print your name 5 different times. So how do? You can like write the word system.out.println name 5 different types. Or what you can do is what smart programmers are going to be doing is that they are going to be taking use of loops. So loops allow you to, and there's some syntax for it, which will allow you to write a simple piece of code and then tell the Java compiler that this block of code should be repeated multiple number of times. And how many number of times and based on what conditions, those are the things that you can actually define. And based on what type of looping mechanism you're using, you can define those conditions in a smart way. So let's just take a look into the types of loops that you have. So the first one is for. So the for loop is basically used when you mainly, or it is generally used in that scenario, when you know how many number of repetitions you need to do. Like let's say if I simply tell you that, hey, print your name 5 different times. That means you know that you need to repeat the code 5 times, right? So you know how many times that whatever block of code you're writing actually has to be executed. In that situation, for is the best. You can use for to do that. In situations when you do not know that is in situations when you do not know how many number of repetitions are there and the condition might be decided during some runtime execution, or there might be some complicated logic in deciding whether you should stop the loop or not. In that situation you should be using the while loop. So in while loop you can give any condition, and as long as that condition is true, other block of code will be executed. And the sister of while loop is something called a do while loop, which is pretty much same as a while loop, but there is only one difference. And the difference is in while loop, before you can execute whatever code you have given, it is going to check the condition and then execute it. But in do while, what happens is it will execute the code and then check the condition. So what it means by that is that whatever block of code you are talking about, that will be executed at least once and then the condition will be checked. But in while loop, what might happen is whatever piece of code you have written, since we are always checking whether you should be repeating before executing the piece of before executing the block of code, there is a chance that if your condition is false right from the beginning of the program, then maybe the block of code might never be executed. That is the only difference that you have between while and do while. And in some tricky situations, in some tricky programming situations, you might have to resort to using do while over while. Okay, there are some special commands that you also need to take a look at while you're using loops and conditions. One is called break and another is called continue. So we did take a look into break when we were looking into switch cases. So break, as it is like break, you must have realized what it does by now. As soon as the term break is encountered by the Java compiler, it is simply going to come out of the loop. It doesn't matter whether there are the condition says that the loop needs to be executed multiple times or not. It is simply going to just come out of the loop. That is what the break statement does. Continue statement does exactly the reverse of it. So if there are 5 pieces of code, 5 lines of code that needs to be executed inside a loop, and in the third line, let's say the compiler finds a continue. What it will do is it is not going to execute the next 2 lines of code. It is going to go back to the loop and start it from where it had finished. So what continue does is continue stops the execution of the statements which are following continue, and it starts or resumes the loop from the next position. So that's what continue does. So break and continue when you're doing some tricky situations, some tricky nested loops and stuff like that, or break and continue comes really handy. Okay, let us take a look into the for loop first. So the syntax for writing the for loop will be that there are 3 different statements that you need to write inside the for. The first thing that you need to write is an initializing statement, which will be executed only once. That is, once a Java compiler sees a for loop, the first statement that you're given inside a for, that will be executing the very first time to understand that, and that is known as the initialization statement. Second is a condition. Condition means it checks whether this particular condition is true or not, and if the condition is true, only then the block of code will be executed. So this condition will be checked every time by the for loop. So for every loop, it will check the condition, and if the condition is true, then it is going to go ahead and execute the loop. And the third statement is known as the iteration statement. So the iteration statement, you actually update some variables on value which necessarily affect the condition. It's better to explain it using an example actually. So if you take an example that I've given here, so the first statement is int idx equal to 0. So this is the initialization statement which will be executed only once by the compiler. So what it is going to do is it is going to create a variable called idx of type int, and it is going to assign it a value of 0. Second thing it is going to be doing is a condition. Condition means it is going, this is the thing which will be checked every time to see whether the loop should be triggered or not. So it says idx is less than equal to 5. So idx already we have given a value of 0. So obviously 0 is less than 5. That means yes, the loop should be executed. So it executes the loop. So what it does is it simply prints the value of idx. Next, what it does is it goes into the iteration state and it executes it. And what does the iteration statement says? Iteration statement says that update the value of idx by 1. So if you were, if you remember, we discussed about unary operators, and this is an increment operator. So what idx plus plus means is increase the value of idx by 1. That is what is meant by idx plus plus. So then it increases the value of idx, and now the new value of idx will obviously be 1. Earlier it was 0, now it is 1. It checks if 1 is lesser than equal to 5. Yes, it is still lesser than equal to 5. It will go ahead and again will execute it. It will come back again. The value of idx will become 2. Again, 2 is lesser than 5. It will be executed. So how long will this continue? It will continue until idx's value becomes 6. So let's assume that value of idx is 5 now. So 5 is lesser than equal to 5. Yes, it is. Means it says lesser than equal. It's not only strict lesser than, it is lesser than or equal to. So 5 is equal to 5. So that means the statement is actually true. So yeah, the statement again, like this system.out.println will be executed. Then the loop comes here and it does idx plus plus. So now what happens? Value of idx is already 5. It becomes 6. Now, if it try to check the condition says is 6 lesser than equal to 5, and the answer is false. It is not. 6 is greater than 5, so 6 is not lesser than equal to 5. So then, what the loop is going to do is the loop is going to exit. The loop is not going to execute whatever is there in the system. It is simply going to count. Okay. We will be doing a very simple program using for each now, just to show you an example of what happens. So what we'll be doing is we'll be printing all the numbers between 1 and 10. Okay. So let us go here. We don't need the scanner of input object. So let me close all this. So the very simple program that you're going to be doing using for loop is we will be printing all the numbers between 1 and 10. So let's call it as I. Let's say I is equal to 0. I is okay. I'll call it as 1. Let's say I is less than or equal to 10, and I plus plus. System. If I do this and I run this, yeah, that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what happened was exactly what I explained in the slide as well, that you are just creating a value I equal to 1, the initialization statement. It will continue to check until the value of I is less than 10. And as long as i's value is not is less than equal to 10, it is going to continue to print the value of I. And after every statement, it is going to go and execute the iteration statement where we're adding the value of I by plus plus. Now we'll do a little tricky programming where we're going to be doing is that we'll be printing the value between 1 and 10, but we will be printing the value with a jump. That is, first we'll print 1, second then we'll print 3, then we'll print 5, then we'll print 7. That is, we are going to be printing only the odd numbers actually. So instead of printing 1, 2, 3, 4, 5, it will be 1, 3, 5, 7, 9. So how do we do that? Is it's actually simple. See, the iteration statement is what you need to target in a place like this. Here, the iteration statement is simply saying one thing, that hey, just increase the value of I by 1. But here I'm saying that you need to take a jump of 2. So probably I can do something like I is equal to I plus 2. And if I execute that, let's see what happens. There it is, 1, 3, 5, 7, and 9. Because first time the value of I was 1, 1 was less than equal to 10. So fine, it's going to print that. Second, when it comes to the iteration statement, it is not going to increment the value of I by 1. Rather, it is going to increment the value of I by 2. So it's going to become I is equal to I plus 2. So it was 1. So it's going to become 1 plus 2, 3. 3 is still less than 10, it is going to print 3. Then again, when it comes to the iteration statement, the statement says I plus 2. So current value of I is 3, 3 plus 2 is 5. So that is how it got printed. Okay. And now just a small trick. So if you actually paying close attention, you will understand this is the way how you can actually print all the odd numbers between two numbers, between two ranges. Now, if I have to print the even numbers, it's actually even easier. I just say I is equal to 2, and that is the initialization value I change. I say the initial value of I will be 2. And if I run this, see what happens. It will just print all the even numbers, 2, 4, 6, 8, and 9, 10. What is the difference that happened? Only I changed the initialization variable. That is, earlier the value of I was 1, and then it was getting incremented by 2 to 2. Now the value of I is 2. So initially 2 will be printed. Then we are doing the iteration statement where the value of I will increase by 2. So 2 will become 4. So then 4 will be printed. 4 plus 2 will 6, then 6, 8, 10. And finally, when I becomes 12, it checks that this condition is false. So it will not print anything and is going to come out of the loop. So that's how simple it is to actually use to use for loop. All right, I'll go back again to the live chat to see whether there are any questions. No, I don't see any questions there as well. Okay, that's fine. Or probably, yeah, no questions. Okay, fine, perfect. Let us move on in the interest of time. The next we'll be doing is again we'll be using for each only, but this time we'll be using a little complicated program. And this what this program is going to be doing is we will be checking whether a number is prime or not. And this is probably, if you're doing competitive programming, this is one of the most not interesting really, but one of the most asked question that check whether a number is prime or not. So a little bit of whiteboarding before we go and start directly. So if you like if your mathematical concepts, if you just go back and refresh your maths concept, you will understand what exactly is meant by a prime number. So what a prime number is, it's a number which has only two divisors, one and itself. That is, it doesn't have any other divisors. Like for example, a number like 7. So 7 can be divided only by 7 and 1. I mean, it can be divided by any number, but they are not factors of 7 actually. So 7 is only one thing, and break 7 down into only one thing, that is 1 into 7. There is no other way how you can actually break 7. If you take in a number like 10, that is not true, because 10 you can write something like, let's say, 2 into 5 as well. 2 into 5 is also equal to 10. So 10 has other factors other than 1 and itself. 2, 5, these are also factors of 10. If we take some other example, like let's say 25. Sorry, 25. So is 25 a prime number? Answer is no, because you can also break it down into 5 into 5 as well. So the numbers which are not prime, they're known as composite numbers. And any numbers which I said, which has got only two divisors, one and itself, that is, there are no other divisor, no other factors of that number, then that number becomes a prime number. Okay. So other examples of prime number would be something like probably 23. So you cannot break 23. 23 also doesn't have any factors. So only factors of 23 are only 1 into 23. There is nothing else. There is no other way how you can actually represent 23. So 23 also becomes a prime number. So now the question is, how do you detect whether a given number is actually prime or composite in nature? So if you see here the examples, you probably will be getting an idea here. See, what we are doing is we are checking that between 2 till this number, whether there are any number which can actually divide it wholly. That is, whether there is any number which is actually a factor of this particular number. That is all I'm checking, right? Like for example, if I take the number 10 here, what I'm checking is from 2, 3, 4, 5, 6, 7, 8, and 9 till, in all these numbers we are checking, okay, is there any number which can actually divide 10 without leaving a remainder? If so, if that is the case, if there is a number like that which will actually be which can actually divide this number without leaving any remainder, then that means, yeah, this is a factor of a number. So hence this number is not a prime number, it is a composite number, if you can find any number like that. So if I write a statement, if I write a sequence like this, 2, 3, 4, 5, 6, 7, 8, and 9, you should automatically switch back to the for loop programming that we just did. So using for loop, I can actually generate a series like this, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So given a number 10, if I write a for loop which starts from 2 and it ends at, let's say, 10 minus 1, I can generate all these numbers. I can get all these numbers. So that is the first step that I'm doing here. So this one I can do it using, let's say, a simple for loop. Next thing that we need to do is, I'm saying that we need to check whether any of these numbers here is able to divide the given number without leaving any remainder. How do we do that? Now for that, again, you might need to scratch your memory a little bit and look into the some of the operators that we saw yesterday. So there was an operator known as the modulo operator, which looks like something called percentage. So what does this operator does? This operator is going to tell you the remainder. That if you divide, let's say you take a number a and you write a modulo b, that means a modulo b will be the remainder when a is divided by b. So when you take a number 2 and you say something like, let's say 10 modulo 2, the answer will be 0. And why the answer is actually 0 here? The answer is 0 here because if you divide 10 by 2, 2 into 5 is equal to 10. So no remainders are left. That's the reason why 10 can be divided wholly by 2. As a result of it, the modulo of this one will be 0. But if you take something like, let's say, just for the sake of example, 10 modulo 3, can anyone tell me what the answer is? The answer will be 3 multiplied by 3 is 9. So if you try to divide 10 by 3, there will always be a remainder of 1 which will be left here. Okay. So that is the concept of modulo. This is how you can get remainders. So if you're trying to find the factor of a particular number, then what is the best way of doing is using the for loop. You have already generated all the possible factors of that particular number. So between from 2 to 9, you have already found it out. Next thing what you need to do is take each number and do a modulo operation with the original number and see what is the remainder. If the remainder is 0, that means yes, that is a factor. And if that number has a factor, that means it is not a prime number. So that is what you need to do. So if we try to write the algorithm or the step for this, so the step for this will be first you take the number, write a loop beginning from 2 till that number, not till that number, till that number minus 1. And then for each number that you have, for each number between 2 to that number, do the modulo operation to check whether that number can wholly divide the given number or not. If it can, that is if the modulo is 0, that means it is a prime number. Otherwise it is that means it has got a factor, so it is not a prime number. Otherwise it is a prime number. That is, if I run out of all the numbers from 2 and I do not find a single number which can wholly divide the given number, that means it is actually a prime number. There are no other factors for that. Okay. So with that particular concept, let us try to do that. So again, I'll take an input. So I'll call it as let's say num input.nextInt. As simple as that. I will run a loop for, let's say, I'll call the loop as factors. Let's not call it as factors. Let's just call it as index. So we start from 2, and index, as we said, it is going to end at 10, not 10, sorry, number, and index plus plus. So this is how I'm going to get all the numbers. Okay. Now what I need to check? I need to check whether the numbers here, that whether this index that we've given here, whether that is able to divide this number properly or not, perfectly or not. So how do I do that? If num mod idx is equal to 0. So what is meant by this statement? This statement means that, hey, I am able to divide this number correctly. That is, if idx is able to divide that number without leaving any remainder. So if that is the case, then what happens? That means then this is a composite number. That is, this is not a prime number anymore. So now the question comes here is, and this is where we will be running, we will be seeing a very cool trick that we do in a lot of for loop programming, and that consists of conditions and everything. See, if you have found the first number, that is, you have found one number which is a factor of this number, that it is able to wholly divide the number, it's able to wholly divide the number. Do you really need to take a look into the other numbers that follows? Let's take an example of something like, let's say 12. Okay. So we have got 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. If I'm checking by all the numbers here. So I see that 2, as soon as it goes to 2, 2 is able to divide 12. 3 is also able to divide 12. 4 is also able to divide 12. 6 is also able to divide 12. So 12 has like quite a lot of factors. But if I have already found out that, hey, 2 is able to divide 12, do I really need to check if there are any other numbers which also can divide 12? The answer is no. I really don't need to check that. Because if the number is one factor, that is enough for me to conclude that the number is a composite number, it is not a prime number. So there is no need for me to check once I've got the first factor, there is no need for me to check whether whether there are any more factors that are for this particular number or not. So what we can do here is, and this is where the statement break actually comes into the picture. I can simply break, hey, break away from this particular loop. I don't need to check anything else. I've already know that this is not a prime number. This is a composite number. So that's the first kind of optimization that we've done here. Now, the second thing that you need to know here is how do you decide that whether the number is prime or not? You decide that the number is prime or not if none of these factors were able to divide the number properly. Correct. That means if this entire for loop was executed and nowhere in the for loop for any number of idx in the for loop, this piece of code was executed. If that is the situation, that this piece of code was never ever executed, only then I can decide here, or I can tell you yes, that the number was actually prime in nature. But now the question is, how do I track that? That's how do I track that whether this piece of code was ever executed or not. For that, we do a concept called flagging. So flag is just a simple Boolean variable. Let's call it as flag, and I'm calling it as, let's say, true. Okay, let's give it initial value called true. And what I'm going to do here is that I'm going to say that flag is equal to false. What it means is that if ever the code is executed here, that is, if inside this if else, if the code ever comes inside this if else block, the value of flag from true, it becomes false. So if I outside of the loop, if I write a question, if I write a thing like this, if flag is equal to true. Now, what is meant by this line? This line means this statement was never ever executed. The code never went inside this particular piece of line. That is why the value of flag, which was true in the beginning, it remained true till the end. Because if this line, because if the code ever went inside this condition, the value of flag would have been reverted to false. But it never happened. The value of flag remained as true. That means the entire for loop was executed, and this statement was never ever was not executed, was never executed. This means what? This is a prime number, because that is exactly the condition that we had. So here I can do something like system dot I can say it is a prime number, and else, that is, if the value of flag was false, that means this piece of code was executed. What I can do, I can write something and I can say it is, sorry, it is composite in nature. Let us try to execute it. So I'll give an input of, let's say, 10. 10, as we know, it is actually a composite number. So ideally the answer should be composite. Let's see if that works or not. It is working. Let us take another number called 7 and let us try to execute it. And the answer of that will be prime. Yes. So it is working as expected. We can give some weird numbers like, let's say, 101. I think it is a prime number, but I'm not sure. Yeah, it is a prime number, right? Let's give some other numbers also. Let's say 6, 7, 8. It should be a composite number because it's ending with 8. It's an even number, so even numbers always have a factor of 2. That's why it's going to always work. So yeah, this kind of program is working. So I think we will call it a day today. We will close this session with this last program on for loop. There are a few other interesting problems that you can also do using for loop. Some of them will be available in the assignment if you have already registered for the course. Otherwise, you can also look into practice by yourself as well. Try to think of problems where you might be using loops and while loops and other stuff like that. Okay, so I'll just take a look into the live meeting once more just to ensure that if there has been any questions or not. Yeah, I don't see there has been any questions. So yeah, then probably I can end it. So once again, thank you everyone who's watching the video. Thank you for taking part here. And as I said, in case you have any further questions, you can always put the question on the comment section and we'll get back to you. And if you have any feedback about the course, any general feedback or any technical feedback about the content of the course or how this course is getting conducted, we would also like to get your feedback. Feel free to post your thoughts as comments on this YouTube video. Okay. Thank you, everyone. Thanks for joining this course. And we'll again meet on the next video where we'll be discussing about some complex data types.